we are going to start with the graph. And we're going to try and figure out what does y equaling the log base 2 of x look like. Okay. So the log base 2 of x is going to be by definition the inverse of which function? This is the inverse of y equals 2 to the x. Now we know what this guy looks like, right? Okay. So if I graph y equals 2 to the x, tell me some things I know about that function. Maybe some points or some other stuff.
How's that the inverse of
That's the definition. We are defining this function. We made up this function so that it would be the inverse of that one. Okay. I know it was like last week and all, but how do I graph y equals 2 to the x?
You plot 0, 1.
0, 1, good. They all go through 0, 1. Okay. What would have been another point? 1, 2. And the third point that we typically plotted was?
-1 and 1 over 2.
1/2. And I got that increasing function. But what property, what characteristic did this function here have before I graph the curve? I have an asymptote, right? That x-axis was a horizontal asymptote. Okay? And it looked like that. And you know what? What was its domain? And its range was?
0
To infinity. Okay? The range was positive values only. The domain was all real numbers, negative, positive, 0, everything. Okay? So if this is 2 to the x, and I want to graph its inverse, graphically, does anyone remember how I come up with the inverse? We reflected over the y equals x line, right? If I've got my y equals x line, I'm going to do some reflecting. Now, point by point, when I reflect something over the y equals x line, what happens to my points?
X and Y flip.
Yeah, I switch x's and y's. So I had one point here that went through 0, 1. So when I twist those, I get 1, 0. I had another point that went through,
1, 2.
so it'll go through 2, 1. And I had a third point,
1/2.
negative 1, 1/2. So flip it, and it's 1/2, negative 1. So those 3 points are inverted. Okay. Also, when I flip, everything x related and horizontal related becomes y related and vertical related. So my horizontal asymptote that was the x-axis, when I reflect that over the y equals x line, I get a vertical asymptote at the, I'm like pointing at it, the y-axis. Okay? So this means I have a curve that this way gets really, really close to that y-axis but doesn't touch across. And this way, it sort of goes like that. Okay? So tell me about the domain of this function. There's 2 ways you can approach this. It's 0 to infinity.
The opposite.
Yeah, just switch.
It's the range of the original function, right?
And then range is all that.
Does the range look like all real numbers? Does it look like it goes to negative infinity that way? And are you willing to believe that it goes to positive infinity this way? It does. It goes really slowly. When you take calculus, you'll find out, like, really slowly. But it does eventually go as high as you need to go. As long as you're willing to go far enough to the right, you can go as high as you're supposed to go. Okay? But domains and ranges switched, right? Okay. I don't know when the right time to spring this on you is, and it's coming to mind right now, so we're going to do this right now. What does that mean? what does it mean to say that the domain of my log function is 0 to infinity?
Positive numbers at 0. And positive numbers.
Can I plug a negative number into my log?
No.
Can I plug 0 into my log?
No.
I can only do log base 2 of positive numbers. The log base 2 of -1 is not a real number. The log base 2 of 0 is not a real number. The log base 2 of 1 is. The log base 2 of 0.00000001 is. But it's got to be a positive number. Okay? So, we're going to write this down. That would have hurt.
So are you saying that, will we never see that, or will you see that and then we're supposed to say undefined?
Here's what's going to happen. I can't wait till we get there. I keep talking about the section 4.5. It's just like the best section ever. When we get to solving some real bona fide log equations, you remember how when you solved radical equations, sometimes you would get answers, sometimes you get solutions that weren't really solutions and you didn't really find out so you checked them? Same thing's going to happen here. When we start solving some log equations, we're going to get solutions that are potentially 0 or negative. And what we're going to have to do is we're going to have to toss out the solutions that would make us take the log of 0 or make us take the log of a negative number. They're not solutions. I don't know if you've read this yet, but you can't take the log of 0 and you can't take the log of a negative number. And that's what this graph has right here. I have no log function over here. Now, why can't I take the log of 0 or why can't I take the log of a negative number? Because our exponential function never went negative. Our exponential function never got to 0. That's the essence of it. If I said the log base 4 of -3 equals what? This is nonsense. Because I'm saying positive 4 to what power gives me -3? It never goes to -3, right? This isn't going to work. 4 to any power is going to be a positive number. It's never going to be -3. Okay?